No,
It's Jacksonville.
it's in Jacksonville,
Okay, so where in Jacksonville?
by the St. John's Town Center,
Okay.
off Gate
So
Parkway.
and what is availability? What kind of company is that?
Validity is a tech company in the healthcare insurance industry.
So you develop all programs for the healthcare
Yes.
services.
Mhm.
Okay, so he has prepared something for us for you guys.
Yep.
So
It's going to be a surprise.
I'll leave you.
Okay, so I'm here today to talk about functions and objects, and I am an advocate for functional programming specifically. I find that that's fine. I find that it can help me write programs that are more concise and code bases that are more manageable. And frankly, if you think of an application, most of what an application is a number of operations on a smaller number of data objects. So without further ado, I guess I'll get into it. So here we go. A function is an operation that takes some data and returns some data. Here's a real simple example, a function that just takes in one parameter and then just immediately returns it without doing anything. Incidentally, this is known as the identity function, and it is a pure function. Another type of pure function would be where you do some sort of manipulation on the data that comes in, and you return some different form of data on your way out. In contrast, you can have impure functions, and they make testing your code difficult because they rely on I/O, and I/O can be messy and unpredictable. So an example of an impure function would be if you had a function in one application that read from a data store that a function in another application running at the same time could mutate. You couldn't reliably say what the input is going to be at any given time, so you couldn't therefore make predictions about how that function will behave in real time. So here's a simple example of that. I'm just taking in a number and I'm creating a random range of integers and then just picking one, or a range of integers from that number to 10 plus that number, and then picking one at random and then just returning that. If I were to run a unit test on this and I passed in 3, the first time that it goes through, it might pick a number between 3 and 13, but the second time, so it could be like 4, but the second time and each subsequent time, I can't make predictions about it. So it could be 3 or 7. Generally, you want to keep impure functions on the outside of your application, and you want to have the internals of your application be nothing but pure functions, as long as you can help it. Now I'm going to talk about different specific types of functions that you might encounter in the wild. All right, there's a predicate, which you would use in a filter function if you have, say, a collection of data and you want to only grab certain items from it. You would pass in a function that takes in that case, it would be a member of that collection, and it would say, just give me the ones that meet this condition. If it's true, it'll be returned in the collection of objects that comes out, but if it's false, it will be filtered out. Here's an example of something that just doesn't take in anything, and it just provides a value. In the very simplest case, we have something that takes in nothing, and it returns something. In this case, it's returning a string, but as the string says, it doesn't have to be a string. It can be an integer, it can be a file stream. It doesn't really matter. A consumer or action takes in some sort of data, and then it does something significant with it. Say, you could do this, print the value, and then that's just it. You don't return any other collection of items. It's something that would just sort of terminate there after you've done your filtering and gotten the objects that you wanted to consume. Functions can accept and return absolutely nothing. That would be an insanely boring function, though. That just takes in no parameters and returns void. It can return any sort of number or text, whether that's like an integer or a float. or actually could return or accept or return Boolean values or text like strings or characters. It can accept and return objects. It can, or they can, accept or return homogeneous sets of data like arrays, lists, sequences, collections, or they can return or accept heterogeneous sets, and that's like a tuple or a struct. Is everybody familiar with all that? Okay, so tuple is pretty cool because you probably learned that a function either returns one value or nothing, right? But what if you have a need for returning two values or more? Well, you can return a tuple, and without defining like an object that has a certain shape, then you can just return like an object on the fly. Think of it like a record or a row in an Excel spreadsheet, or a row in a database. All right, and if you're working with a language that takes in functions and can return functions, then you're in luck, because you have some real power with that type of a language. I'm kind of going to go a little academic for a minute, so just bear with me. But I guess we're out of college, so that's okay. So here's an example of something that takes in two integers and just returns their sum. That's pretty familiar with all of you, I'm guessing? Yeah. All right. Now here is something that takes in a parameter and returns a function that takes in another parameter and then adds them. So what you would return is a partially applied function. So the function that would come out of this function is defined right here, and the x would be applied right here. So you could, yeah, def add 2. So I'm not incredibly familiar with the syntax of Python, so let's see if this works. So if you ran this, val would be equal to 5, because you built a function called add2 because it's going to, this build adder is going to return a adder function that already is going to say, well, we're going to accept one parameter and then add 2 to it. So we'd pass in the 2 here for x, and then we would return 2 plus y. Not really thrilling. All right, and then there is the idiomatic way of doing this, which if you're not familiar with lambda, it's just a stand-in for a function that doesn't have a name. You'll see in the above example, I named this function that I defined adder, and then I returned it. But down here, I'm just saying return a function that I'm not going to name that takes in y, but x is already provided for me in the builder. So I could do the same thing as I did before, and val would still be equal to 5. Okay, and then this is just the way to do it for Python if you want to take in a function that takes in a function, and then you apply the function to the value that's passed in. All right, now on to some objects. So here we have a person, and before I go into this, like obviously an object can be a collection of data and operations, but for the purposes of this lecture, a person or an object is just, I'm just going to use an object as a struct, a glorified struct, basically. It's going to be a collection of different types of data. So name is a string, age is a number, and licensed will be Boolean. And then there's inheritance, where you could take a more abstract or general concept of an object structure and then have more concrete examples or implementations inherit from that, and it will get all of its properties from the parent class. So I'm going to define a vehicle as something that is like drivable and terrestrial. So it's going to have wheels, and it's got to have some fuel. So wheels and fuel will just be two integers. I'm going to define car as a vehicle, or car inherits from vehicle, and it takes in a make and a model. Now, in this constructor, sure, I'll pass in the make and the model to the car, and those will both be strings. And then I'm going to say it's going to have 4 wheels, and we'll fill up the tank. We'll say 100 fuel is a full tank. All right. Some other examples of inheritance. Let's say you have a result class. This is going to take in a value of some sort and a message of some sort. And I want to say, well, I know every operation that I perform will return a result of some sort, but I want to know if I need to continue processing. If I want to continue processing, it's going to be because every prior operation that has been applied to the data in our application has been of a successful result. So success and failure will inherit from result. And basically, they just have the same constructor as their parents. Okay. And remember the identity function that I talked about before? What unit is going to be is just optimistic. It's going to say, all right, I'll take in whatever you pass into me, and I'm going to wrap that with no message into the success type and return it. And you remember from the example here where you can have a function that takes in a function and then applies it. Now here I'm going to have some logic around that. So I'm going to call this function bind, and it's going to take in some value x, and it's also going to take in a function f. And if x is of the failure state, continue on. Just return x, whatever was passed in, I don't care. Otherwise, we're going to apply the function that was passed in to the value in x, because it's a result and it can have a value and a message. Then I'm going to print the result of applying this function to the value of the result that was passed in, giving me a different new result because the state in my application has now changed. And then I'm going to return that and be on my way. Okay. One more thing. I will get to workflow next. So let's say you have this other definition of a function called workflow, and it takes in some value, and it takes in a collection of functions. So for each function in the collection of functions, f's, use the bind function on the function that you're on currently and the data that you have, and you just basically what this is called is like the trampoline, where you just keep updating the value of y.
Trampoline?
Yeah. Because instead of creating a bunch of new variables, you just keep updating the one that you have right there because you only really care about the last result in the for loop.
I like the analogy.
Yeah, I didn't come up with that. I think that's from Clojure. All right, so then return y. Okay, so now we've got all of that under our hats. Does anybody need any extra explanation for this? Nah? Okay. So my favorite question was always, when are we going to need to use this? So let's scroll up. Okay. Ignoring all the imports that we have from the other Python scripts, we're going to do something involving a person and a car. And it's going to be driving that car. Now, one of the problems that I encountered when I was trying to architect a purely object-oriented solution was, well, where do I put the responsibility of drive? And do you put that on a person, because a person can drive a car, and then that method would be on the person class, and it would take in a vehicle? Or do you put that responsibility on the vehicle, and it takes in a person, and then seemingly drives itself? I could never find an answer that satisfied me. So I said, well, I just want to get things done, so why don't I just have a workflow that takes in person and car and changes the values on those data structures? So just for starters, we're just going to say the driving age is 16, and we're going to find a couple of functions. We're going to say a person is of age. We're going to take in a pair. Actually, really, this would be just the value. It's no longer a pair. Sorry, when I created this, it was a pair, but now it's actually a triple, which is a tuple that just has, there we go, 3 things instead of 2. Again, you should just refer to it as a tuple, but I didn't refer to it as a tuple because apparently in Python, tuple is a keyword, and it would shadow that, and I think that's bad programming practice, so I didn't do that. We're just going to call it x. So in our tuple, I know that well, I can just show you. Right here, I'm going to say, give me a person. Where we have name, age, and licensed. So the person's going to be Sam, Sam's going to be 20, and Sam will be licensed. Similarly with car, make, and model. And if you remember from the car class definition of its constructor definition, you take in the make and model, and then you just give it 4 wheels and a full tank of fuel. So we don't have to define that here, it's just assumed. We're going to drive a distance of 90, and here's that workflow, and I will talk about this later, but this is the end result that we're working our way to. So we're going to check a couple things. Persons of age, their license, the car has wheels. Obviously, I was struggling to come up with operations that we want to do true or false, success or failure states for, and then we're going to actually drive. All right, so if the person is less than the driving age, then you return a failure state with the value that was passed in, the tuple that was passed in, and the message, so-and-so is only so much and needs to be at least this to drive. And then you just fill that string up with the person's name, age, and then the driving age. If you're not familiar with this, this looks for the very first thing, this looks for the second thing, and this looks for the third thing that's passed into the format function. And incidentally, this makes string an object because string is like its own array of characters, which is some data, and it has this function on it called format, which will return a different string. Similarly, for success, if the person is at least the driving age or older, then you just say this person is this age, which it is so-and-so, which is of driving age. There we go. I was wondering why that was weird. And then you format that string, put it in your success state, and just be on your way. So you'll notice that all of these functions, well, let me get there. All these functions are going to return a result, and it's either going to be success or failure. Where when we bind, we check to see if it's a failure state, and then we just sort of don't care. We don't apply this function. All right, so if a person is licensed, we grab the person from the tuple. And then license is just a Boolean, so we say if that's false, then you return a failure state, so-and-so is not licensed. Otherwise, you say, hey, it's a success, they've got their driver's license. This one's seemingly silly, but it does serve a good example. It shows you how you can unpack stuff that's sent in. So here I know that this is going to have person, car, and then a third variable that I don't really care about. So I'm just going to do underscore, and that'll signify to future developers, which may include myself, coming back here days, weeks, months later, that value that's in the tuple that's passed in, it doesn't really matter for the purposes of this function. So we create the message one way or the other. It's going to be said, you know, hey, this car has this many wheels. And if there are 0 or fewer wheels, then it's a failure. You can't drive that vehicle. You can't drive that car. Otherwise, it's a success. Right.
project is they're taking a car example and applying it to a restaurant or ice cream store.
Okay. I did not know that. Bear with me, and then I'll show you how, when all of this comes together, you can do some really cool things. And then finally, you're going to drive the car. So we're going to unpack the value that comes in. We know there's a person, then a car, and then a distance. And we're going to take the max of the difference between the fuel and the distance, because we're just going to say, you can go 1 mile per fuel, whatever. And then that will be the car's current fuel. Drive is obviously optimistic and just assumes that you do have enough gas, else you're just going to run out of gas. So here we go. If you turned out to have run out of fuel, it says so-and-so's make and model ran out of fuel, or it will say so-and-so drove X miles, and here's the remaining amount of fuel that's in the car. So let's put all these together and see that this person is of driving age, the distance is less than 100, and they're licensed, and a car has 4 wheels, so we're good there. So we're going to run this unit test. Oh yeah, and then we're going to get the result out of this workflow, and then we're going to assert that the result is of success type. Oh my god, my code worked on the first try. This never happens. Okay,
No errors.
so here's all the logging. Here's the power of why you want to be able to bind functions and compose them with each other. Say your boss comes to you and says, okay, that's really great, but now can you tell me how long it took to do each operation? Here, you could grab the start time, and then here you can grab the end time, and then here you can calculate how long the op took, and then you can print that out here. You can say, in 2 seconds we concluded that Sam was 20, and that's of driving age, which is 16. And then you could add in here, just for purposes of demonstration, you could add in like a sleep thing, sleep for like 2 seconds, and then it'll pop up, or like 5 seconds, and then it'll say like, hey, this operation took much longer than all the other ones. It took 5 seconds. You might want to look at how this function is built. It's just useful information that you can get. And then you don't have to like pollute the rest of your code base with the code that actually does the thing it's supposed to do intermixed with like all the code that does the logging and the error checking. So to prove that this actually works, let's have some fun. Let's say Sam is not 20. Sam is 2. That's not old enough to drive in any state I've ever been to.
Actually, they found a dog driving the other day.
They did?
They didn't have a driver license.
What? It's still printed
It
under 3.
did, because I messed that up with indentation. Let's see, this should work. Dang it.
I mean, he's licensed.
I want to do that. There we go. There you go. Sorry, that's what happens when you make last-minute edits right before a talk. Invariably, you introduce bugs, but hey, that's an opportunity to learn, because this is why you write unit tests. You wouldn't want to have sent that code out to production if it was responsible for automated driving or launching missiles or whatever. So Sam is 2 and needs to be at least 16 to drive. Sam will go back to being 20. And let's say we drive too far. Sam's Honda Civic ran out of fuel. And then in the weird case, we can mess with the underlying values of vehicle, which car inherits from, and say we have 0 wheels on this car. Sam had a run of bad luck. It was not successful. And Sam's Honda Civic has 0 wheels. This logging doesn't have to be printed to the screen, as it is in this case. it can be printed to whatever sort of logging software that you have in your production-ready application. And um, another benefit to writing and organizing your code this way is that you can, for example, show your boss, look, I created with the data that came in this workflow, which checked in this list fashion that the person is of age, the person is licensed, the car has wheels, and then it drives. Your boss can say, okay, that makes sense. But otherwise, your boss would have to know, whatever programming language it is that you have. Now, you might still have bugs in your code like I just showed, but it's easier to find them if you do this than it is if you don't use the fact that some languages can pass functions into other functions. So let's say that we don't have workflow. We don't have the ability to pass in a set of functions and then loop through them and then apply them to our data. Here's what that would look like. So we have the same Sam, 20 years old, Honda Civic, and he's licensed. Now here it is without workflow. Actually, I have to expand the screen now. So here we're nesting all the calls to bind with the data that comes in and then the function that may or may not be applied. The same thing will happen, but you can see that clearly it's easier to understand this and there's less to have to wrap your mind around than there is with this. And you're also introducing the arrowhead, tornado, or some call it the Tasmanian devil anti-pattern. Here you can see, where that name comes from. The code still works. It's just more difficult to spot if there's bugs in it. And there's, the more of a cognitive overhead that you'd have to deal with. Just to prove that this still works the same, we're going to make Sam 2 again. Poor Sam. He's only 2, and there are so many responsibilities foisted upon him. Okay. This can get even worse.
Actually, I was 14 years old when I got in my mom's car, and I drove her car to the corner, and there was police in the corner, and I ran back to my house.
Yeah.
Got out of the car and got in my house. Police came in the house. My mom was so mad, not at me, at the police, for chasing an underage kid.
Yeah.
She was so mad that she almost killed the guy.
Oh my God. That's crazy.
She was so mad, and I was just went in my bedroom high,
Mm-hmm.
like nothing happened.
Yeah, like nothing happened. Trying to be
14 years
innocent,
old.
right?
That's crazy. Yeah. So, and then we can still do like weird stuff, like say car wheels is equal to -1. I didn't say it was like the real world. See, Sam's Honda Civic has -1 wheels, so we're not going to drive a car that has wheel debt. All right, so that's what that looks like if you don't have the ability to pass in a collection of functions and then apply them to your application's state. Now, here's how it can be even worse. Let's say you don't even have the ability to pass in a function to another function in the language that you're using. So in this scenario, you have to intermingle all of the actual logic that your program performs along with all of the stuff you are able to abstract away using function application. So in this code, you're going to see all of the tests being run. You're still not going to see the guts of, say, person is of age, person is licensed, has wheels, or drive, but you are going to see a check to see that is everything okay after I did this applied this operation. Let's log the message that came out, and let's continue on. So if you thought the arrowhead pattern or tornado pattern or Tasmanian devil pattern was bad here it is without bind. So this does the same thing. Yeah, it sure is. that's pretty much all I wanted to say about the power of functional programming. Um, does anybody have any questions or requests?
Not anymore.
There is one way. I didn't have time to do this, but there is a way to implement this using objects that contain these functions, but I didn't have time to implement it because I only had so much time, and it just really would have just. I mean, I can't even like this is hard for me to wrap my mind around, and I wrote this just a few minutes ago. Putting all this in
We
objects.
still got like 47 minutes if you want to try to wrap your head around it now.
All right, so here we go.
Well, you really presented us with a perspective in programming from the actual workplace, which working with other programmers. Do you guys have any questions regarding that? I mean, this is kind of interesting because one way is
I want
when
to
you
see one
start.
of the programs you worked on at your job.
I'm not sure I'm allowed to
I
show.
know.
I can't even show like a screenshot of my laptop if I'm just looking at the time.
Well, yeah, they're probably not.
No, they're very strict. There's all sorts of hippie stuff, and
Yeah,
Yeah.
I understand that.
yeah.
So, but there are you see all the considerations that you have when you're writing code, because someone else is going to be using the same code. So, and I noticed that you use very few comments on your code.
Oh yeah. Okay, so another benefit of doing this is that you've now broken up all of your functions into operations that are so small. It's very easy to test them. They don't really do that much, and honestly, that's a testament to going this route as opposed to going this route because both of these they do the exact same thing. It's just one is a ton more code to have to deal with.
Yeah, you can say that again.
Brandon, you have questions?
Not particularly.
Okay.
So, how many people work on projects with you?
Where I work, we have relatively small teams. It might be 2 or 3 other people that, like at most, are working on like the back end system. Might be 2 or 3 people at most that are working on a front end system for a given part of the company's overall API or other applications. But the company that I work for currently has like hundreds of developers.
So, do you guys like break down and like you do one thing, they do another thing, and then after a while you guys come together and try to put it together?
We try to do that like at the same time. So like I'll talk to the front end team for the team that I belong to and say, hey, here I'm making some changes to the shape of the data that's coming back down to the client. Just be aware of them, and then we can roll out our changes to production together.
Have you ever ran into the tornado?
Oh yeah, no, I mean so the reason I wanted to share this with as many people as I possibly could is because I don't ever want to have to debug this. Would you? No.
Yeah, because a problem could be anywhere within there.
Yeah.
Remember the movie with Chevy Chase, the light bulbs in Christmas?
Oh yeah. One goes out.
Looking for that light bulb.
Yeah.
I don't know the thousands of light bulbs.
Derek, I had a question.
Oh yes.
What is the pay rate?
It's good. It's good. I've worked at like 5 other places, and this is the best I've ever had.
So it's like roughly between 30 and 40. Like 40, we starting off with like 40,000 or better.
I started off my career at 40,000. I was lowballed as low as 20,000. It's just anecdotal.
So
I mean, your luck might be different, but
entry level, it's kind of between 20 and 40. Would you say?
no, like I said, I felt like that was trying to offer me less than I was worth at the time. I honestly feel like 40 is not enough for someone with like a 4-year degree that did really well in school. That said, there's an entire culture out there that sort of looks at you as just being green, and you know, you graduate college and you think I am ready to enter the professional class, and then everyone else there who's been there for a while, like, will just say like, "Oh, great, it's someone fresh out of college." So this is one of the things that I had to do to teach myself. This is one of the things I had to teach myself in order to be a more succinct programmer. Yeah, because you can write this fresh out of college. I was not taught how to do this, or uh, much more the value of it, and that's kind of why I'm here right now. I want as many people to know this as possible. Yeah, there's real value in it. It's a real time saver, and honestly, I hope I never see code like this again.
Like programming is really hard. So I'm like, if it's really hard like that, I know it gotta be some good paying.
Oh, yeah, yeah,
Well, hopefully it is.
And especially there, it's all based on market, supply and demand, and the programming industry is like, I mean, we have, as I heard this from a USA business center in downtown, they say that there are thousands of jobs coming to Jacksonville, to North Florida,
yeah. Oh, yeah.
and there
The
is
world's your
not enough
oyster.
programmers.
But my advice to, well, get a couple years under your belt, learn security as well, and then honestly build your own thing. Don't sell just your time and labor for the rest of your life. Build a product and sell it to people, whether it's other consumers directly or businesses. You can get more than a good salary that way. Is what I'm saying.
Yeah.
Okay.
So you have your own set of clients and your own set of programs that you work with.
No. I don't take my own advice. I just give it freely. Yeah, but that actually is something that I came to the conclusion of very recently. Yeah, you can get a very good salary doing this, but you can,
probably make more making your own program.
yeah, if you have your own business, if you
Another
build your own
question
product,
that I
yeah.
always hear from students leaving the program is, so which language should I learn or be specialized? What the market is looking for? Which is the language?
So it's going to be basically some sort of C style. It's going to be either C sharp or Java. But I just taught myself Python, in my free time over the last 3 weeks, of which I didn't really have that much free time. And so, once you learn the basic paradigms of programming, then you're good. I just wanted to give this little lecture about the power of functional programming because I was not exposed to this, and I was only taught OOP. And frankly, I think OOP is still pretty hard. This is easier to me.
Okay, so you said the codes vary and are different in some ways. Do you have anything that you could show us from like Java or C++? Like
I mean,
to show us differences?
honestly, yeah. Here's what this would probably look like. So this is Python. What would this look like in a different language? It's been a while since I've done unit testing in C# or C# in general, because where I work, it's a Java place. Something like this.
So I know main routines in programming, it doesn't really matter which language in general, because you're still gonna have to apply decision structures, loops,
Yeah, yeah,
arrays, and so on.
yeah.
Well, yeah, but what I was asking was like certain things like there he has VAR, which probably means variable in
Yeah,
front of everything.
It does.
And that's C sharp, right?
That is.
Plus,
I mean, like I said, it's. Whoops.
There will be some particulars about the syntax, but
That's basically what I'm trying to explain
well,
too.
I
Yeah,
asked
exactly.
Because next semester I go into C. So I want.
and you're gonna be doing also in
I
a
want-
Windows environment, by the way.
Yeah, I just wanted to see,
a
you know,
visual
get a
editor.
comparison, a visual comparison.
Yeah.
Now, why I have a chance because we have a master programmer.
Oh, thank you.
Well, that's what you went to school for, right?
So you can see that it's. I mean, it's basically the
Instead
same
of
thing,
itself,
you
it's
know.
an assert.
There's just punctuation that's different. Like this, var, and then new. It just says that this is going to be a constructor. We're going to instantiate a new person. We're going to instantiate a new car. I mean, I could go on, but like I said, it's basically the difference is like punctuation.
Any other questions from Gary?
This is really screwing with me taking English at the same time.
What?
I got an English class too.
Oh, okay.
Trying to write code and doing English is like two completely different languages, obviously. but
Yeah, yeah.
You got capital letters where capital letters shouldn't be. You got
Oh, right.
and then I'm trying to go to an English class right after, and oh shit, I forgot this comma, or there's supposed to be a period. Why am I putting brackets in here?
Yeah, if you do that in an English class, you might lose a couple points. If you do that in a programming class, your program won't compile and you fail the project. So,
Any other questions? How about the frustration of writing a program? Do you have any questions on that? Jennifer
How many
Fowler.
hours did you work?
it's just like the typical 40 hours a week. Well, there's also like, we'll do like an evening deploy on most Wednesdays. And if it's not on a Wednesday that week, then it's Saturday morning. And usually that means that I'll be online for about 2 hours, give or take, while the code is deployed and someone then comes along after it's been deployed, a QA person, and then checks to see if there's any bugs in it. And
So how often that happens when you deploy a new improvement onto a program?
well,
I was gonna ask him.
that's the whole reason why you want to develop your application alongside a suite of tests. Because you want to catch those bugs while you're developing. That's called at development time. You want to catch your bugs at development time as opposed to at runtime, as opposed to at deployment time, as opposed to worst case scenario when your customer interacts with the application. Because the later you wait to catch those types of bugs, the more time it takes, the worse it is for the reputation of your company, and frankly, just it is more expensive financially to catch those bugs later in the game than it is to catch them right at development time.
So do you have any opinions about the deployment of was that the IRS a couple of years ago that launched the program for, it wasn't the IRS, was the Obama healthcare program, Obamacare.
Oh, yeah, I was actually on that.
Oh, you're the one that screwed up the program.
No. I was I was a consumer of that service, not a producer of that service.
But I hear that was total disaster. So
No, I mean, I didn't do it right when it came out. I waited a couple of months before switching careers or jobs, and then using that. And I would just say it wasn't perfect by the time I got to it. After a couple months, it was just like, oh, this is, I had my opinions about it. I have nitpicks, but I mean, I was able to get health insurance through the marketplace.
talking about, oh yeah, it was a terrible program. They spent millions and millions of dollars trying to fix it, but they never say why. And now you come here with the functions explanation, which makes sense. So it could be part of the problem.
It could be. I have absolutely no background information on that. I didn't even look into it because, as far as I was concerned, I just wanted to get health insurance.
All right. Any other questions? Well, thank you.
Sure thing.
That was very useful.
Thank you.
Appreciate it.
Oh,
Dragon game.
Dragon game.
What do you think about the dragon game?
Me?
Yeah.
It's a good introduction to like using the console.
Yes, it is.
Yeah.
I know we struggle with it, but it's actually fun.
For you, maybe. I get eaten every time I play.
Which is your favorite programming language?
F sharp. That was easy.
Brandon?
F sharp.
Never heard of that. I've never heard of that.
Water?
Oh, sure.
Yeah, it's
I don't like that.
it is Microsoft's implementation of
Not chips?
ML, which is meta language, which is a language that evolved or was invented after Lisp was created. Oh, thank you. And it is where I learned how to do what I just showed you guys.
Thank you.
Oh, so if you want to learn more about this subject, I stealthily snuck into all of your minds and taught you monadic bind.
What?
I
Monad
didn't even know what bind was, and I'm just looking it up here.
Monadic bind?
monadic bind. If you want to look up another example in Python, you can take a look at this. It's called Monads in 15 Minutes. It's by this guy, Nikolai Groziev. And where I got introduced to monads was from this guy. He is a really, really smart F sharp enthusiast, and he's worth following on Twitter. And I guess if you guys want to follow me on Twitter, you can. I'm at Klamarama, Klamarama. Yeah, this is really useful. This is a video of the concept I just taught you guys. You bind together little functions like that are built like this that it can either say, okay, pass along a success state or pass along a fail state. And then when you bind them all together like that, you end up having one giant, in this case, the metaphor he's using is that of a train going across railroad tracks. And then, other metaphors that you can use are pipelines. And the one that I prefer to use is a workflow. Any questions?
Do you have any projects that you're working on, like specifically, like not for your company?
No.
Do you have a plan to?
Yeah, I do. I actually want to get into game development. You do?
Oh, you like game development? You
That-
don't like games.
That's what I'm wanting to do.
Yeah. That's what made me bite the bug back when I was a kid. I thought it was really cool.
That's why I'm sitting here at 41 years old.
Mm-hmm.
I got out of the army and said, well, I need something to do.
Hell yeah.
Okay, I got a question.
Sure.
And it might be kind of like a crazy question, but
I've got crazy answers.
with gaming, with programming.
Mhm.
But programming is basically like when you try to do gaming, it's basically you making up your own game.
Yeah.
So like people who, like say Mortal Kombat for example, somebody came up with a program for that.
Yeah.
And then I was just playing it just regular, and they did all the dirty work.
And then what did all the dirty work?
Like the programmer did everything, and I'm just playing it.
Yeah, I mean, there's also probably some sort of artistic element too. You have to have the sound effects just right, the music just right, the graphics just right. For example, it's not all just programming. you wouldn't want to have two different Mortal Kombat characters where one looks like it's like a Monet painting and the other looks like it's a character from Family Guy. Like artistically, that would clash and it wouldn't really work, regardless of how well programmed it was, like the characters moving across the screen, jumping and kicking.
Yeah, I was kind of lost because we talking about gaming. I'm like, so do you just sit and make the program for it?
From what I understand, most games are a little bit of programming and then a lot of art assets. Like anytime you play just even like the first Super Mario Brothers, there's a little bit of logic regarding the trajectory of your jump and how that depends on how fast you're moving at the time that you hit the A button. But there's just that, and then there's like some collision detection, but there's far more bad guys and power ups and soundtracks and sound effects in that cartridge than there is programmed logic. Yeah.
I just watched this one thing on YouTube. This guy, he lives in Japan, and he does videos in the day, a normal day in the life of this person and that person. And he did a gaming programmer from Bandai,
Hmm.
and he was asking some of the random people. They were all split up. The one dude he was following was doing coding, and there was a meeting in the back of people who were working on Tekken 7.
Oh, cool.
It was pretty neat looking at all that. It was funny because there's this hidden room where they can go and take naps in.
Oh yeah, yeah, yeah.
I like watching the dev blogs of Blizzard.
Yeah.
I'm a big Blizzard Entertainment fan. I've got owned all the games from Lost Vikings.
Oh my God, I love Lost Vikings. I'm hearing the music right now.
I still play it every so often.
Hell yes.
But nowadays they'll do like dev blogs and you can see some of the things behind the scenes that they're working on and stuff like that.
Yeah.
I always wanted to bring them an idea that I had for a game to have just that stamp because it's a multi-million-dollar game company.
Right.
Just to have that stamp Blizzard written on your game, it's gonna skyrocket.
Yeah, sure. I mean,
As long as it ain't a flop like
exactly.
but the last game they put out was one they mixed with I think it was Activision. They tried to redo a Call of Duty. It ain't selling so hot.
Okay.
But Activision really wasn't.
You don't necessarily need to have a big publisher like that if you can do your own PR, because sure, you might get that, but you also might get struck by lightning.
Yeah.
You don't have to make all of the money. You can just be satisfied with making some money, to quote a YouTube personality that I like to follow.
I just hope Diablo 4 don't flop.
I've never played those games. My friend in high school, he loved Diablo 2 so
I
much. But
played all of them,
nice.
and I still do the seasons for Diablo 3.
Okay.
But they're getting ready to release Diablo 4.
I have heard that, yeah.
So do you do any like personal coding when you're not at work? Like have you tried like making a game or anything?
Yeah, I did a couple years ago. Actually, in high school, I made a Final Fantasy clone, but that was so many years ago that it probably wouldn't be impressive now. It looked like a Super Nintendo game.
Well, I don't know. It depends on.
Yeah, okay, so it had like a...
Depends. We're both Final Fantasy fans. So.
All right, how about Final Fantasy 4 or Final Fantasy 2 as it was released in the United States?
That one wasn't too bad.
Okay, that's what it looked like.
Not for the graphics of that era. No,
I copied that style, and I had a map that would be blank when you started out, and as you moved around the world map, other parts of it would be exposed to you, and then it would record that, and then you could just have it was like a mini map you could see in the overworld, where you had been, what the whole map would be if you'd moved everywhere. It of course had random encounters, it had special moves, it had magic, it had health, and all this was written in QBasic. On a Friday afternoon, after coming home from high school, I was so excited about it that I wrote a standalone, separate application for it just to do graphics for more monsters and stuff.
What did you use for the graphics and stuff?
I had to teach myself like anding and exclusive ORing and stuff like that. That's like when I first learned about that in order to have like colors added to the colors that had already been printed to the screen for a given map tile. You had to use exclusive ore to.
Surfaces.
Yeah. Well, it was overlaying sprites so that since they were like additive or something like that, you could get like goofy colors if you put one sprite on top of the other. Since it's like adding, 37 to 78, that
Yep.
gives you a completely different color when you really want to just have one overlap the other.
It's like the opacity of the color.
Right. Well, additive, like the additive value
Okay.
of the color at a specific picture element. Yeah. That was a long time ago. That was like 1998.
That was about the same age as my sister.
Yeah,
She was like
you ain't too much
96 or
younger than I
97.
am, actually.
I'm 36.
I
About to be
graduated-
37.
I graduated in, well, got my GED in 2002, but I was supposed to graduate in 96.
Oh, one.
Okay.
That's it? Okay.
Appreciate it.
Of course.
Thank you very much, Gary.
Just so you know, I didn't feel like coming in. He's the only reason I came in today.